Sanbonani Abafundi, welcome back. Today we're going to be looking at something called sigma notation. Now sigma is actually a Greek letter, and the Greeks designed a lot of the mathematics. They came up with it and they sort of discovered it, and that's why we encounter quite a lot of Greek in maths. Some people say maths is Greek. It's not Greek, it makes sense, but we have come across other Greek letters. For example, pi, the pi is a Greek P, but this is going to be a Greek capital S. Let's dive straight in and see what it looks like. Okay, so this symbol over here, and I'm going to try and write one, they're actually quite difficult to write, is a Greek capital S. Okay, we are also, if we haven't already, you may already have encountered another symbol, the Greek lowercase s is also called sigma, but it's the small one, and this one is used to represent standard deviation in our study of statistics or data handling. Okay, we're going to be talking about the big one. And the big one, and remember, it's an S for sum. So what sigma notation means is it means adding up. Right, and what we're going to do, I've written down the explanation here, but we're just going to show it to you using an example. So for example, when we write sigma, sum, from I equals 1 to 5 to I plus 3, what we are saying is put 1 into the, replace I with 1 in here. So 2 lots of 1 plus 3, 2 lots of 1 is 2 plus 3 is 5. And then plus, and remember it's going to be plus, and the reason it's going to be plus is because that's what this symbol means. It means add. Okay, sigma, S, Greek S for sum. Right, now, next up we're going to put 2 in for I. 2 times 2, 4 plus 3 is 7. Then we're going to add, when we put 3 in for I, 2 times 3, 6 plus 3, 9. Then we're going to put 4 in for I. 2 lots of 4 is 8 plus 3 is 11. Then we're going to put 5 in for I. 2 times 5, 10 plus 3, 13. And then we're going to stop. Now, why did I stop at 5? And after 5 terms, all right, I stopped with 5 because that was the number on the top. So let's just understand. This number over here is the first number I'm going to put in, and then I just go up one number at a time until I get to the top number. Now, if we look at what we've got over here, this is a series, all right? It happens to be what sort of series? Arithmetic or geometric? It happens to be arithmetic, okay? We could add these terms up. We could use a formula. Given that there are only 5, let's just add them in our heads. 12, 21, 32, 45. I might be wondering whether that is right, so I'm going to add them the other way around. I'm going to add them from the back to the front. 24, 33, 45. Okay, often in life and often in maths, we want to do things in 2 different ways and confirm that we get the same answer. Then we can be quite confident about the fact that we're correct. Okay, so let's do another one. All right, okay, sorry, this is not another one yet. What we're saying here is that the answer to this series is 45. What this is a shorthand, a shortcut, a short way of writing all of this. Okay, so that's all sigma notation is. So kind of a shortcut for us. Okay, so what we want to show you is that it wouldn't matter if instead of using I, we used J. Because if we use J, then the J's would be replaced by 1, 2, 3, 4, and 5. Or if we used K, right? Most commonly we use I. So I is the one that we get to see more often than anything else. Right, Penduli Kasi, turn over the page. All right, and what we want you to do now, we're going to ask you to pause the video and we're going to ask you to try these next 5. Or in fact, maybe don't try all 5, maybe just try the first 2 and then let the video run again and we'll see how you've done with those. Okay, let's take a look. Sorry about that. Okay, let's have a look at this. So the first term here is going to be 3 times 1, 3 minus 7, negative 4. The next one, 3 times 2 is 6, take away 7, negative 1. Notice the plus because we are adding. The next one is going to be 3 times 3, 9 minus 7 is 2. And the last one is going to be 3 times 4, 12 minus 7 is 5. Right, those are the terms. Notice that there are only 4 of them, and that's because I runs from 1 to 4. Let's add these up now. Negative 4 and negative 1 is negative 5. Negative 5 and positive 5 is 0. They cancel each other out, and we get a final answer of 2. Okay, let's look at the next one. So this time, we're not starting at 1. That's interesting. We're going to start with I being 5. 2 lots of 5 is 10, minus 1 is 9. All right. And then notice I'm not saying plus 3, and we'll talk about that. This is quite important. There's this here is the sigma notation. We're going to add 3 at the end, and that's really important. If we wanted to add 3 to each term, we would need to put brackets in over here. Right, there are no brackets, so we're just going to add 2i minus 1 with I running from 5 to 9. Okay, so the first term was 9. The next term, when I is 6, we're going to get 12 minus 1, we're going to get 11. Just going to keep using my green pen, hopefully. 9 plus 11 plus, remember it's plus, plus, plus. It's always plus because sigma means S. It's a Greek S for sum, add up. The next one, when we put 7 in, we're going to get 13. When we put 8 in, we're going to get 15. When we put 9 in, we're going to get 17. And we stop there. And the reason we stop there is because that is the number where we stop. Okay. Now, don't forget, at the back here, we've still got a plus 3. So our actual final answer is going to be 20, 33, 48, 67, 70. I'm going to check that. I'm going to add it backwards. 22, 37, 50, 61, 70. Allah, Allah. Okay, right. Let's look at the next one because it's also got an interesting idea here. There's a variable in here. Now notice we are not going to put the values into the x's, just into the i's. So let's take a look at this one together. Right, if I is 1, we get 2 lots of 1 is 2 plus x. That's our first term. I'll just put it in brackets just to sort of separate it. The next term, if I is 2, we're going to get 4 plus x. And if I is 3, and this is going to be the last one we're going to do because there's 3 at the top, 6 plus x. Okay, so there it is, and we stop there. Now the final answer to this, obviously if we add these up and we collect our like terms, 2 plus 4 plus 6, 12 plus 3x. Okay, the next one, in fact we're going to ask you to pause the video and we're going to ask you to try the next 2 yourselves, see how you go with them. Okay, so this one over here, fairly straightforward. We're going to put 2 in, we're going to get 2 cubed. We're going to put 3 in, we're going to get 3 cubed. We're going to put 4 in and we're going to get 4 cubed. Right, and now we're going to stop at 4 because that's the number at the top. 8 plus 27 plus 64. Really helpful if you know your numbers. 8 and 27 is 35 plus 64. 64 and 35, we can do that in our heads, 99. Okay. All right, and then the next one, and this is important because it's important in terms of order of operations. We are going to square and then double. We are not going to double the number and then square. All right, so if we square 2, we get 4, doubled is 8. If we square 3, we get 9, doubled is 18. And if we square 4, we get 16, doubled is 32. And there's our answer, right? 8 plus 32 is 40, 58. Okay, right. Now, we're going to just make sure that we think carefully about the number of terms. So when it runs from 1 to a number, then it's easy. It's obvious. If it goes from 1 to 4, there are 4 terms. 1, 2, 3, 4. However, when it runs from, like, for it doesn't start at 1, it's harder to tell. Here, if we go from 5 to 9, you might say, Paul, if we go from 5 to 9, the difference is 4, there'll be 4 terms. They're not actually 4 terms. If we count them, there's 1, 2, 3, 4, 5. I'm not adding that. That 3 is not part of it. All right. So in fact, there's actually one more than we might have expected. All right. Another way of thinking of this, if we went from 1 to 9, obviously 9 terms. But we're missing from 1 to 4. We're missing the first 4. So if there should be 9 and we're missing 4, then there should be 5. It makes sense. It always makes sense. Look at this one. It runs from 2 to 4. Right? The only one that's actually missing is if it started at 1, there would obviously be 4, so there must be 3. 1, 2, 3. We're going to give you a little rule here. The rule makes perfect sense. The number of terms is going to be the number on the top minus the bottom number plus 1. Okay, have a look. 4 minus 2, 2 plus 1 is 3. 1, 2, 3. Right. Now, we're going to ask you to do these. We're not going to ask you to write them out in full. We're going to ask you to write down some terms first to make sure what you are dealing with. Is it arithmetic? Is it geometric? That's going to help us decide which formula to use. But with all of them, no matter what formula you're using, please make sure that you're adding the right number of terms. Let's do the first one together. Okay? We're just going to write down the first 3 terms. When we put 2 in here, we get 2 times 2 is 4, plus 5 we get 9. When we put 3 in, we get 11. 6 plus 5, 11. When we put 4 in, we get 13. And this carries on. Okay. Now, what sort of sequence is it? Is it arithmetic or is it geometric? It's arithmetic. That minus that is 2. That minus that is 2. It's definitely arithmetic. So now the last thing we're going to do, well, not the last thing, we're going to just make sure that firstly that we're using the right formula. Here's the formula for an arithmetic series. Do I know A? Yes. Do I know D? Yes. Do I know how many terms there are? Careful. Remember our little trick? 68 minus 2, that's 66, plus 1, 67. We need to find the sum of 67 terms here. Now, it's going to be 67 over 2. 2 lots of A is 18. 2 lots of 9, 18. 66 times D. And D is also 2. And there's our answer. Okay, from here it's just a question of getting a calculator. Okay, just to re-emphasize, if this went from 1 to 68, there'd be 68 terms. We're missing the first one, which is why there are 67 terms. Let's take a look now. Okay, so what we've got 67 over 2. And then we've got some brackets. And we've got 18 plus 66 lots of 2. And we get 5,025. 5,025. Right, we're going to ask you to pause the video and try the next 3. We will go over them. We'll go over them once you've tried them. Okay, so let's look at this one. If we write down the first 3 terms, the first term is 500 over 2. The next term is 500 over 2 squared. It's actually 500 over 4. And the next one is 500 over 8. Now, is this arithmetic or geometric? Are we multiplying by a fixed amount or are we adding a fixed amount? You can use a calculator if you need to, but we're hoping that you can see that in fact the bottom is it's doubling. So in fact we actually, R is a half, okay? This is geometric with R equals a half. I'm going to show you that if you couldn't see that easily, let's remember how we check what R is. What we do is we take any term and we divide by the term before it. So let's take this term, 500 over 4 and divide by the term before it, 500 over 2. We get a half. Okay, we'll get exactly the same as if we took 500 divided by 8 over 500 divided by 4. Right, so now we need to make sure we're going to use the right formula. Remember, the formula is Sn is A lots of r to the n minus 1 over r minus 1. You can swap those 1 minus r to the n and so this should be r minus 1. You can swap them around and have 1 minus r, but if you make this 1 minus r, this one must be 1 minus r to the n. Okay, now how many terms are there? Well, there's obviously just 7 terms, but even now, if we use our little trick, top minus bottom, 6 plus 1, 7. Okay, so let's have a look. The sum of 7 terms is going to be A, 500 over 2, and we've got r is a half to the 7, I like to just put that in brackets just to be sure, minus 1 over a half minus 1. Let's pull up our calculator and see what we've got there. Okay, and what we've got there is as follows. We've got 500 over 2. I'm actually going to just do that in my head. I'm going to go 250 times by, all right? And now on the top here, I've got 0,5, that's what a half is, to the power of 7 minus 1 over 0,5 minus 1. And I get that, right? Let's just see what that all comes to. It comes to 496,09. 496,09. Okay, before the next lesson, try the rest of these questions. They get sort of, some of them we're looking for different variables, and we'll try them in the next lesson. But at least have a go at C and D before the next lesson. Okay, all right. Have a good day, and we'll see you on the other side.